Hello, good morning, welcome to Multipath TCP. Could we ask volunteers to take some notes, please, probably in the Etherpad, easiest way of doing it, but we need a volunteer or two to take some. Hello everybody, welcome to the meeting. Thank you all for coming. So we've got a couple of people who are going to take some notes, one offline and one in Etherpad, but if you can help out in the Etherpad, that would be great, please, because I think it's easier as a collective effort. So I'm Philip Erdley. I'm one of the chairs of the group. Yoshi can't be here, but he's online as well, remotely. Now you'd think that would move it down, wouldn't you? But no, that one maybe. If somebody can keep an eye on Jabber, that would also be good. Please remember when you come to the mic to say your name, preferably slowly, so other people can understand you. The blue sheet, we only seem to have one, which is starting over this side. Please keep it moving and make sure it gets over to the right or left-hand side, whichever way up you are. Here's our usual note well. You're invited to note it. Here's the agenda for today, which you're welcome to bash. In terms of our formal charter, the good news is that the BIS document, our protocol, which is now on the standards track in the BIS, I've pushed the button a little while ago to send it off to our AD, who's Mia. So she's planning to review that after this meeting, and then we'll find out what she wants to do with it next. But anyway, hopefully we're not too far away from getting it into the rest of the ISG and for publication with luck. So thank you to everybody over the long period that's gone on for, and to Alan, who's been handling the updates of it. So in terms of the agenda, we've got a normal kind of slot for implementation news that we always have. We've then got a couple of talks about deployment news, so they should be very interesting, so that's good. We've then got three talks based on individual drafts, and then at the end we've got a discussion time to talk about potential future topics for the working group. So I guess this would imply a rechartering. We had a side meeting on Monday about potential future topics, which was very good. I've got a few slides, or a slide later to just introduce that, and Anna's going to give us a quick zap about TAPS, which came up as being related, and probably we ought to be better informed about here. So we'll start off with the implementation news. Is Christoph here yet? Christoph here? He usually has implementation news. Do you want to say anything either about the mainline efforts and or about the hope to get the BIS open source code?
For open sourcing the BIS implementation, I at least at Apple, I have now the approval to open source the handshake. And so I will do this maybe this afternoon when I have time, and post it at least as a request for comments to the NPDB developers mailing list.
So we're getting closer. It's nearly there, is it?
Yeah, now it's just a question of me doing the posting of the
code. Oh, really? You've had permission?
So the permission is there, yes.
Oh, fantastic. Oh, that's great news. Yeah.
That's good.
Thank you because I know that's taken quite a lot of effort with the lawyers. So yeah, thank you, and thanks to the Apple lawyers for agreeing.
Yes, it took a long time because of the patent, but now we have the approval to open source everything.
So I mean, and that's great news, and I think it also means that it gives a chance for more people. Obviously, you guys have tested it and all of that, but it gives an opportunity for more people now to do that. I guess we have a small window too, if we need any changes to the BIS, any clarifications or whatever, as a result of people's tests. So encourage you to do them as quickly as possible once it's available. That's great news. Thank you.
And then for the mainlining Linux kernel efforts, there's now the open source community that is working on that is growing. There are now a few people from Red Hat and a few people from Intel working on it, as well as Tesseract, the startup in Belgium. And we are making good progress. Some pieces for frameworks have already landed upstream a few weeks or 2 months ago or something like that. So we are making progress, and eventually we will be getting there. From the maintainers of the Linux kernel, we have the support to do it. They want us to upstream it, so it's going well.
So that's also good news. Thank you. Excellent. So we always have a moment for an open mic, just if anybody else has implementation news that they want to share.
another implementation news. Apache Traffic Server now, at least the developing version, now allows to enable MPTCP. So it's evolving towards full support of MPTCP for the traffic server.
Okay. Okay, so let's move on to the two talks about deployment. So we got Olivier on remote. Now let me try and get your slides up here. Now, I think I probably have, do I have to hit this button? Probably, don't I? Now, Olivia, I've tried hitting the red button.
Yes.
Excellent. So I think we're ready for you. Thanks.
Okay, so sorry for my voice, which is disappearing. Next slide, please. So the objective of the presentation is to give feedback on one of the use case for MPTCP, which has been using MPTCP to deploy a hybrid access network that combine both LTE and DSL together to improve the bandwidth, mainly in rural areas. So as an example, this is a portal that the European Commission is publishing based on the quality of the access link. And the lighter the color you see, the lower the bandwidth that people have. So there are still many countries in Europe where a large part of the country have a very small access speeds. And by combining DSL and LTE, you can improve the bandwidth. So next slide. So the idea is very simple, and we have been discussing it a lot in the past. So you have TCP connection that go to the hybrid CPE that has both LTE and DSL access, and it converts the TCP connection created by the clients into multipath TCP, go through a hybrid access gateway, and the hybrid access gateway uses regular TCP to reach the final destination. In this example, the final destination is IETF.org, that, as far as I know, does not yet support multipath. Next slide. So let me just give you some feedback on the deployment of this use case. And there are two issues in this deployment that needs to be taken into account. First issue is how do we change the CPEs and what kind of CPEs network operators will deploy. Basically, what happens is that the network operators, they have to install a multipath TCP to TCP proxy on CPEs. And we have seen three types of deployments. First approach is to add the MPTCP proxy in an existing DSL CPE and attach this existing DSL CPE to an LTE CPE, for example, with a gigabit Ethernet interface. The advantage of this solution is that you can reuse the existing CPEs, but many of the DSL CPEs have a low bandwidth, have a low speed CPU, and this restricts the bandwidth that you can get. A second deployment is to use a hybrid CPE that combines XDSL and LTE on the same box. Usually those boxes have a more powerful CPU, and so this gives better performance, but the cost for the network operator is to replace all the existing CPEs. And the deployment that seems most interesting for the network operator is to keep the existing DSL CPE with a very small modification that simply redirects IP traffic to the LTE CPE and put the proxy on the LTE CPE. And the two CPEs are connected by using gigabit Ethernet, and you implement the multipath TCP proxy on the LTE CPE. Next slide. So here is an example of how it works. So there was supposed to be animation, but let me just describe what happens. So you
I'm
have
going to try and switch to my PowerPoint slides.
if you have PowerPoint, it might be easier, but.
This is going to work. Oh. No, that won't work. I haven't got the right connector. No, sorry, Olivier, I haven't got the right connector on my laptop, so.
Don't worry. So the client creates a scene, which is sent through the hybrid CPE. So the hybrid CPE will convert the scene into an MPTCP scene with the MP capable option. It goes through the HAG. Then the HAG will send the scene to the final server. The final server returns the scene plus HAG to the HAG. The HAG confirms the establishment of the connection from the final server. Then it replies with a scene plus HAG with MP capable to the hybrid CPE. And the hybrid CPE sends the scene plus HAG to confirm the establishment of the connection through the client. At this point, we have 3 TCP connections, so one from the client to the hybrid CPE, one from the hybrid CPE to the HAG, and one from the HAG to the final server. And the HAG can send an ad address option to advertise its IP address on the LTE network. And at this point, the hybrid CPE can send the SYN plus MP join to create a subflow over the LTE interface, and it's possible to use both DSL and LTE for this TCP connection. Next slide. So the second deployment model is to run the proxy on an LTE CPE. In this case, the DSL CPE is simply modified just to forward the IP packet by firewall rules to the LTE CPE. So the SYN comes from the client, it goes through the DSL CPE, the DSL CPE forwards it to the LTE CPE, and the LTE CPE does the proxy and sends the SYN plus MP capable to the DSL CPE, and the DSL CPE forwards it to the HAG. And the advantage of this solution is that all the other packets are the same, but the advantage is this solution is that you can leverage the more powerful CPU on the LTE CPE and keep the existing DSL CPE. Next slide. In the other direction, if you. So that was the previous slide. Can go next and next. Yes. So one question that network operators often ask is what's the performance that you can get on hybrid CPEs? In practice, this depends on the CPU. So to give you an idea, we have run some experiments with an off-the-shelf CPE, which is the Linksys 1200, which is using an Armada CPU at 1.3 gigahertz. And we've connected it to 2 Ethernet interfaces, one with a 20 millisecond delay, and the other with 20, 50, or 80 millisecond delay, because we know that for MPTCP, a difference in delay can affect the performance. So we try to see what the total bandwidth that multiple TCP connections from the client to the server can use in this environment. So next slide. So the measurements on the x-axis, you have the total bandwidth, which is the sum of the DSL and LTE links. So from 16 to megabits per second to 1 gigabits per second. And you have 3 curves that indicate the total bandwidth that we can get. So up to 500 megabits per second, there is no impact of the difference in delay between the DSL and the LTE network and the LTE link. Above 500 megabits, there is a small difference, and the higher the difference in delay, the lower the throughput. This is not surprising. And the other factor is the CPU usage. And so the CPU usage becomes a limitation when we are close to 1 gigabits per second. But based on what we see in rural areas, we never reach this kind of bandwidth. Next slide. So the second point is the hybrid access gateway. So there are 2 different deployment models for this hybrid access gateway that terminates the MPTCP connection in the operator's network. So one approach is to use a centralized hybrid access gateway if the DSL and DLTE network converge only in the backbone of the network operator. And typically you would have a large HAG in this case. If you have a network where the DSL and the LTE network share multiple locations, for example, they use the same POPs, then it's possible to implement the HAG very close where the two networks are present, and you can then run the HAG on a standard 86 server or inside the virtual machine. And the next slide gives you an example from one deployment. So that's a HAG which is placed in a POP. The top of the figure shows you the CPU load on the HAG, and the bottom part of the figure shows you the link load. So this is a HAG that during this measurement was serving about 7,000 users. So during peak time, it had about 200,000 Multipath TCP connections that were active, and we saw about 6,000 or 7,000 MPTCP connections being established every second. And what we see on the bottom curve is that the total throughput, which is the green curve, the top green, the largest green curve, the total throughput, which is 10 gigabits per second. This is mainly incoming traffic, so traffic coming from the internet to the DSL CPEs. These are home users, so this is not surprising. And then if you look at the two other curves, the two blue curves, we see that in this deployment, the DSL and the LTE network carry about the same amount of traffic, although the LTE network has much more capacity than the DSL network, and network operators, they try to first fill the DSL pipe and then move traffic to the LTE network only when this is required. Feedback from users is very positive. And when looking at the CPU load, you see that with 10 gigabits per second, the CPU load is not more than 25%. Next slide. I think it's the last one. So we can say that Multipath TCP brings some benefits for hybrid access network, and it can boost internet access. There are different deployment models for CPEs and for HAGs. And maybe one interesting point for the working group is that the work on MPTC proxies that we did in the past in this working group, and then that moved to the TCPM working group, which is now the converter protocol, has been accepted by the 3GPP to provide access traffic steering, switch, and splitting for 5G networks. And so we might see a growing number of MPTCP-based services in 5G networks as well. Thank you. I think this was the last slide.
Questions and comments? Some people are coming.
I'm Rahul Jadhav from Huawei Technologies. So I have questions with regards to the use of converters. So you mentioned use of transparent proxy. So with the use of transparent proxy, is there really a need to use a converter on the client side?
So you can, the converter is a decision that you can take mainly for the HAG, not for the CPE. So on the CPE, you use a transparent proxy because the CPE sees all the traffic. And then it's a decision of the network operator whether you use a HAG with a transparent deployment or a HAG with a converter. So there are advantages and drawbacks with both solutions depending on how the network is organized. If you want to do a transparent deployment, then you have to configure your routing so that all the traffic goes through the HAG. And if you use a converter, since the converter draft as the HAG as a unique IP address, then you don't have to change your routing configuration.
Okay, thank you. So another question with regards to the converter. Do you think extending the converter to support like policy decisions such as the scheduler policy can be added to the TCPM converter? Do you think it makes sense? Because right now, the way I see it, there is no way to control the policy from the scheduling policy that can be used.
Oh, what we see with network operators is that they control the scheduling policies on the CPE and on the HAG.
Okay, thank you.
Hi, Olivier, Florin Babescu, Broadcom. First editorial, I think on the BBF WT item, you may correct 348 instead of 378.
Yeah, that's a mistake.
Second, few corrections, at least if we are considering the BBF deployment scenarios in the context of the 5G. Based on the current agreements in the 3GPP, none of the deployments that you show are actually going to happen in the release 16. We only have a multipath TCP proxy, which for the BBF will going to be in the HAG and not on the CPE part.
So for 5G, the MPTCP will be on the end devices.
On the HAG in your particular figure that you put it. It is not fully finalized for BBF, but that is overall intention.
Okay.
And the last message, as you already put the draft IETF TCPM converters, from the 3GPP perspective, this one would be in the fast path because practically we do have a dependence now on this particular draft.
Yes, but this was discussed on Monday at TCPM.
Markus Amen from Deutsche Telekom. I have several questions about the hybrid access you proposed based on Multipath TCP. So first of all, I wanted to ask the deployment you already have, I think in Belgium. Is there a specific scheduler applied, or is it the basic RTT scheduler?
So that's a deployment in multiple countries. And the scheduler has been optimized to utilize the DSL network first, and then the LTE network afterwards. So this applies to both scheduler and path manager. So the hybrid CPE will only initiate subflows over the LTE network if the DSL network is fully used.
Okay. Second question. So you presented a performance measurement, enabling the Linksys router with Multipath TCP, and you presented there that you were able to reach up to 1 gig, if I remember correctly. Was this a single TCP flow, or did you make this measurement with several TCP flows?
So this was with several TCP flows.
Sorry?
This was with several TCP flows.
Okay, because that was also some experience from our side that you can only leverage multi-core CPU if you use multiple TCP flows for a single TCP flow. Then one core is limiting the performance, and I think that is also your experience.
Yes, there is but it really depends from one CPE model to another.
Okay. And the last point I want to make is, so we as Deutsche Telekom have the hybrid access available since several years in Germany, but also now we are working on having this, to deploy this in all of our footprint. And as you know, I think we have a GRE approach to cover the IP. The IP traffic in general, and I think Multipath TCP itself is a good alternative for hybrid access, but with the increasing quick traffic, we have also to cover, we have to handle this somehow, and from an operator perspective, I think it's not a solution to just cover the TCP traffic, because if you want to design some tariffs, maybe, which includes the hybrid access benefit, then you can't explain to a customer that only TCP services can benefit from hybrid access, and that's why we propose to establish somehow a multipath UDP to complement the multipath TCP in that sense.
Yes. I hear that, but I see that if you look at BBF, so BBF has agreed to do both the GRE approach and the MPTCP approach, and we will see what operators will deploy. So there are deployment for both solutions, and for QUIC, we will see once QUIC is finalized, how it can be supported over multiple paths correctly.
Marcus, so I don't want to get into non-multipath TCP discussions too far, but is there a place people should go and look to follow that multipath UDP work? Where should people go to follow your multipath UDP work?
So I proposed this as a TSV WG. So I think I will start now again the discussion on the mailing list. And if someone wants to participate, then
so that's where to go. Florian.
Yeah, so Olivier, as you may be more familiar actually with the discussion in the BBF, what is the issue actually using multipath TCP as a tunneling mechanism for all the IP traffic between the HCPE as well as the HAG? Has this been covered in those discussions?
What do you mean by using the for all traffic?
Same like L2 VPN going over multiple access. So the egress interface of the whatever is 5G RG, I would call it in 5G, and whatever is a hybrid access gateway would establish a tunneling mechanism using multipath TCP as a transport over which it can carry any IP packet. Have you seen any issue?
Well, if you want to do that, the issue is that MPTCP will give you a fully reliable transmission and in sequence. And there are many applications that don't need that. And it would hurt some applications if you ensure that everything is in sequence and reliable, because it will increase jitter and create problems.
I think, Marcus speaking again, 1 or 2 years ago, there was a discussion on the multipath TCP mailing list about that, where someone tried to encapsulate UDP traffic to send it over multipath TCP, and it was agreed that this is not a good design decision, and there's a performance lag at the end.
Any more questions or comments? Okay, thank you very much, Olivier.
Thank you.
Oh, I pressed the one that's got the big arrow on, telling me to press it. That's probably better. Lucky somebody can read.
Okay, good morning, everyone. I'm very glad to have the opportunity to share with you some information about multipath transport deployment on smartphone. Okay. Doesn't work well. Okay, much better, right? So I will talk about multipath transport deployment on smartphone applications. My name is Cao Zhen, and this is a joint work with Huawei Protocol Research Lab and the Consumer Software team. In this talk, I will cover 4 parts. First, what has been done and lessons we learned and the issues we found, and concluded by some thinkings about future work. To start with, we deploy MPTCP on Honor V20, one of the flagship products of Huawei Honor brand, since this January. And up to now, around 7 applications has been enabled, and more are coming. And we made this happen by through the direct collaboration with the third-party mobile applications and the cloud and the CDN providers. And we leave the decision to take down and off to users through a UI called network acceleration in the system settings. And in addition to MPTCP, we also support UDP or UDP multipath through user space networking to complement the scenarios where applications only use UDP flows. And although the above scenarios is only operating in China geographically now, we are working hard to bring it somewhere else. And in the current deployment, our product team pays a lot of attention to the scenarios that may be intuitively be benefited by coupling Wi-Fi and LTE together. The first case we look at is the video downloading, because in typical Chinese VOD application, there's a feature supporting the user to buffering the video content so that it can view them offline. And in this scenario, if the user can coupling Wi-Fi and LTE together, they can boost their downloading speed. And the other use case is mobile live video. In this case, the user experience may be improved in broken and weak Wi-Fi scenarios. And the other very important use case is mobile online gaming, in which the low latency is very crucial for the users to be competitive in those games. And also when users are doing vertical handover between Wi-Fi and LTE, MPTCP can also make their connection stable and seamless. In general, the user experience has been improved. For example, in video downloading, their speed has been accelerated in general, and also for the live video case and also the online gaming case, the experience has been improved when any path has been congested. But we still meet some counterproductive cases where improvement is not visible, and we are working hard to work around that. And for that, because we just deployed that since this January, we keep collecting user feedback on this feature, on those features. So there are two flavors in the current deployment. First one is the direct end-to-end MPTCP conversation, where we provide SDK to application developers so that we can glue their application stack to the MPTCP stack. And also we provide the necessary guidance for the cloud infrastructure if they need any guidance there. And the second case is the MPTCP proxy. Well, we are very lucky to working with cloud and the CDN providers in China, including Huawei Cloud and also top-tier CDN provider called Wangshu in China. They are proxy the MPTCP traffic to regular TCP traffic for their customers. And here are the lessons we have learned. And because we actually starting to looking at MPTCP 3 years before, and when we talk with product, the smartphone people told us that the simultaneously use of multiple link without user permission is not a good idea at all. And user will definitely complain about that. And also the network people told us that the mailbox is not ready and the running service over split path is very hard to operate. And also the mobile application, on the other hand, are in favor of the upgrade if their user experience can be improved. Otherwise, any upgrade to their cloud infrastructure couldn't happen any sooner. We take some steps to overcome these issues. First of all, we design a special UI to allow user opt-in explicitly so that we can shift the choice to the users. And secondly, we notify any data usage over the metered link so that the people can be aware of that and can take it off if they don't like it. And also, but we believe that this is less the issue because the data plan keeps becoming cheaper. And for the network issues, we just found that some ports has been taken special care. For example, port 80 and 8080, it has much higher success rate than the other ports. And also in those cases that mailbox is very unfriendly to MPTCP session, we make sure that we can fail over to regular TCP quickly. And for the mobile application side, we believe at this point in time it's very crucial if we can work closely with these mobile application vendors so that we understand their scenarios. We try to persuade them to update MPTCP on a small set of use cases first of all, and try to explain to others in the long run. We also find performance of MPTCP is very important because user expects much more if the two links are turned on simultaneously. Now I will talk about some issues we faced. First one is priority while scheduling. So if MPTCP, as in the left figure, it shows that if MPTCP connection majorly consists of downstream flows, and one link is one path is Tor and the other one is Tor free, it's very important. The user generally requires that more data scheduled to the Tor free link and then overflow to the Tor link, right? So to the meter link. But the issue here is that the cloud side doesn't have any information about which path is Tor free, which is not. And also by using the current default scheduling, more data will be scheduled to the meta link if it's quicker. And the challenge is here that there's no way in the current spec to mark the fine-grained priority of the flows other than backup bit. And also the client doesn't have any fine-grained control over the scheduler used at the server, the other side. So luckily this has been discussed. Yeah.
Last second, so the client actually does have this if you set congestion experienced, ECN code point.
Excuse me?
If you set a CE mark on as a client on the path you don't want the server to use towards you, it should slow down, right?
CE mark.
If you set an ECN congestion experienced
okay.
on the path that you don't want the server to use.
But ECN doesn't work. I'm not sure if ECN can work with the MPTCP scheduler.
It's a
because I want to saturate the top three first of all, and then offload to the other one. ECN cannot do that, right? This is our empty.
So you know, the congestion window will close on that path, right? And that will prevent the use of that path pretty effectively if you keep sending a bunch of CEs. Anyway, you should investigate this because I think there is actually fine-grained stuff that would apply here and would work. And we don't, and so you might not need a mechanism at the MPTCP level because you have a mechanism at the IP level.
Yeah, hopefully it works.
Stuart's going to tell me why I'm wrong.
Yeah, we'll do some investigation.
No, I just came up to clarify because I heard a question that wasn't actually answered, and it's very simple. The question was, does ECN work with Multipath TCP? The answer is yes. Yes, it does.
So that was Stuart Cheshire, by the way.
So Anna Brunstam, I just wanted to add to that, Lars, but if you close the congestion window on that path, then if you actually need the path to send data, you can't do it, right? So
yeah, that's a better answer.
So you want to have the one path as the priority, but you may want to use your second path. So if you close the congestion window on that path.
So let's design this.
Okay,
no,
cool.
so the sender would obviously try and retry and reopen the congestion window along the less preferred path. Right, so there's not really any mechanism to say, you know, you shouldn't ever use this for anything. There's only an ability to shift most of the traffic off it, but that's like good enough, right? Everything else will be massive control overhead.
Hey, Lars, join your discussion on the mailing list because this was has been recently discussed on the MPTCP list, and it is obvious that it's not a problem, just a VMAT.
Sure. I guess my suggestion is to investigate that mechanism of using ECN to have the client notify the server about, well, implicitly tell the server which path it doesn't prefer to use at this time and have the server periodically see if the client maybe now prefers that path.
Yes, maybe we can use that complementary.
And it could be done without any changes to MPTCP, which is like the nice thing, right? Because it's not like MPTCP isn't like complex enough already.
Markus Arment, Deutsche Telekom. So in general, this question was just put here to exchange policies between Multipath TCP client and server has to be discussed, and I think that was also some conclusion of Multipath TCP site meeting here at IETF104, because maybe you can solve this specific issue with priority scheduling with ECN, but I'm not sure at all. But there are also some other use cases. So maybe if you want to agree on the SRTT scheduler, then the ECN does not work anymore. And though there should be a way how Multipath TCP can at least exchange some information, and maybe about path manager, maybe about path scheduling, and so on, so that the remote peer is aware what is maybe wished by the client, and maybe afterward then some negotiation can follow.
Okay, sure. Yeah, the other issues we met is the aggregation performance. This is old issue because when users are using multiple paths. Is that clarification questions?
No. Last second. So I want to push back, right? Because MPTCP is really already complex enough, and the client can already close subflows if it doesn't want them to be used, right? And so there is already a whole bunch of machinery that's available instead of inventing new stuff, right? And negotiating policies inside TCP. Please, let's not do this, right? I mean, it's very clear that I'm like on the extreme end of being very disappointed of MPTCP turning into a proxy solution for operators, right? So this is, you know, for everybody should be clear that this is where I'm coming from, right? But it's just nuts to do this at this level. Please, let's not do this.
Yeah, one look at the Orange. I think that's, yeah, before deciding whether we need to do it or not, I think we need first to understand the problem here. So I think basically the one simple problem is when you have, for instance, a volume quota on some subscription from the users, and the server doesn't know if there's any, I would say, limitation of the data which is sent by some network. So if the server just blindly, or I would say randomly select a given network attachment and send all the data through that path, the subscriber will find himself at the end of the day only single attached. So we are losing. If there's a policy which is, I would say, not that well implemented in for the server, we'll end up with a customer which is single attached and not multipath anymore, because we reach the quota on some subscription. So I think that's, yeah, we need to understand the problem of the policy here we are talking about. Is it whether to unify the remote endpoint about my preference in the way it will inject the traffic through my network attachment? This is what we are talking about, or something else? I think that's the congestion and the policy distribution is not the same in the same level. We need to distinguish them, and let's try to understand the problem before deciding or discarding the point.
So we're kind of getting into the discussion we were going to have later, but I don't mind having it now. That's okay. So I think something that came out on Monday and from the last 5 minutes to me is that we need people to write down what the problem is that they're trying to solve, without writing down an attempt at a mechanism to solve the problem.
Yeah, I think we have.
You know, the last 5 minutes we've been trying to do both simultaneously, with people saying, here's the problem, here's a solution. No, that solution's not good enough. Here's the mechanism I would like to use to solve the problem. Let's work out the problem is accurately first, or the problems, because people have mentioned all sorts of things.
Yes.
And I think that would be really helpful, because I know there are people who think it's important to solve particular problems. But when we've had the discussion before, we've ended up in a position where we've not come to any agreement about any mechanism to add. And I think that's because we haven't had proper agreement about the problem. And we've been trying to do two things at once, talk about problems and mechanisms. So I think,
I think
really
it's
like
better
us to only do one of them first. But anyway, sorry, we've had quite a lengthy interruption to Zen.
Exactly.
So please keep going with your presentation.
I think
Come
it's
back
better
to more discussion later.
Continue the discussion on the mailing list, because there already has been discussed and a lot of people raised this issue, and we can see how we handle this. We can just close this, or we can just go on with other ways. And the other issue is aggregation performance. To be simple, because when users are using multiple paths, we usually generally expect that the performance will be better than any single path. And the problem is that if the quality of the two paths depart from each other, the aggregation transmission is less efficient than the best available path alone. And we know this is a hard problem, and because the fast path is not fully utilized in this situation, and spend a lot of time waiting for the slower one. And also sending on the losing link is a sacrifice of the opportunity of sending it on faster link. And around the issue, there are many academic work, but unfortunately, none of them has been standardized or generally proved solid. So I think I do not have an answer how IETF could react to this, but I think document the problem and possibly some schedule to avoid performance degradation will be helpful to the ecosystem. And the other issue is the low latency multipath transport. We found the issue with MPTCP in this case. If there's a mice flow, the MPTCP cannot acquire the RTT of the unused subflow, because there's no data overflow to that flow. And how, for example, in this figure, if the Wi-Fi becomes weak, how does the client know that switching to LTE is useful or not? Is better or worse? And equally, when the client is only using the LTE, how does it know it should come back to the Wi-Fi if Wi-Fi rarely recovers? And there are some solutions around this. First one is active probing of latency via spatial frame, or we can just make before break by bridging to the redundant model, which is also specified by the MPTCP current schedulers. Yeah, and the other issue around the low latency is the path manager. The problem here is that, for example, on the figure, if the client and cloud side has two IP addresses assigned from different ISPs, A and B, if the subflows are established between the IP address across different ISPs, this will be resulting into suboptimal performance, and it will be much better if we can do it like to make sure that the IP address from the same ISPs were paired correctly. Yes, only clarification questions, okay, otherwise I don't have time.
On your current thing, why do you even need to use Multipath TCP for a mice flow? At least when
this
use
is a low
proxy.
latency case, I'm saying. For example, the gaming, online gaming. MPTCP was designed to be robust and stable. That's the major case.
Nothing comes for free, so it comes to a cost. At least when you use a proxy in the network, actually, that may not be a good way to use the resources.
That's a good comment. But that's also...
Hi. Could you go back to your last slide? This one, yeah, okay. Thank you. Last I got again. So I would actually suggest that this is not a problem that we need to deal with, because so naturally the scenario on the right should be the one where those two paths see much better performance than the other two paths. So even if all four are tried, right, the traffic should sort of naturally be on paths that go through the same operator network. And whatever mechanism you have to not transmit a lot of data down lousy paths should already get you into the situation. If you are in a situation where the one on the left actually gets the client better performance, so be it, right? And that I would not understand how this is possible, but I think the other mechanisms that you have described already solve this, and we might not need something special for this case.
Sorry, I don't get your point.
So you're saying you want to go from the left to the right, and so you would like a mechanism to not have the client not even try to establish these cross ISP flows.
Exactly.
What I'm trying to say is these cross ISP flows should have much worse performance than the flows that stay within one ISP. And since you already need a mechanism to push the traffic to the better flows, that was your previous slide, right?
That's for the low latency one.
It's for all traffic, right? It is not only for low latency, right? So you whatever other mechanisms you have that try and optimize use of the multipath connectivity should already deal with this case. And if they don't, then they have other problems that need to be fixed.
Okay, I understand your concern. You are saying that this problem exists, but the previous solution may solve this problem already.
So this is a problem, but I think this should already be solved by whatever else you have to make multipath in general work.
But so what else you mean? What you just is trying to say no?
I'm saying you might want to keep this as a scenario to verify that what you've built works, but I don't think you shouldn't need anything special to address this scenario other than what you already have for the other scenarios.
Okay.
So this is a useful test case to see that it actually makes that shift from the left to the right, but it should come automatically.
I understand. At least we have a consensus that this is the scenarios, but we are not talking deep into the solution right now.
No, I was saying you might not need a solution specifically for this scenario if the mechanism you build works well.
Okay.
Thank you.
Thank you.
Just a clarification question, if possible.
What's your name, please? Your name, please?
Benedict. So do you have any data of how often this happens, just out of curiosity?
Oh, if you are using full mesh, this happens all the way.
Okay.
I'm going to talk about the connection establishment, which is an important component for both high throughput and low latency. And if the initial path is broken, the connection will fail. And the initial path is lossy, the overall performance will be degraded. And there are some solutions documented well by the Robbie solution from the Deutsche Telekom expert. And I will not cover much about that, but my colleague Zhu Jianjian will also cover to talk about the need to couple with the Robbie with initial path connection. There was some discussion at the site meeting on this Monday, and there was some concerns about the server burden using this approach. But I would prefer to document this at least as an experimental document and overcome the software server burden issues through software engineering approaches outside IETF problem. And the last issue is the load balancing issue, because we must make sure that two subflows with different IP address may map to the same IP address, same server IP address. There are some solutions around this. First way, we can wait for a stateful multiple TCP load balancer, or we can just make some minor change to the protocol, and one of which document in Olivia's document listed here. But if Robbie is turned on in this case, we probably will need to revisit the load balancer protocol changes here. Then the fact a lot of people have talked about MPTCP in the 5G scenario, because the 3GPP guys has a very clear vision that put an MPTCP proxy in the network side, and they are also thinking about using the ways to bundling the UDP flows, and one of which has been talked by also by the Dr. Marcus on the hot RFC session this time. Yeah, to summarize, I talk about the existing use case on smartphone applications, and I also list some issues we faced, and also some perspective looking ahead. With that, I'm happy to take questions. I already take a lot. Yeah, please.
So if you go on previous slide, as a figure, it is not quite correct. It only covers the release 15, untrusted non-free GPP access. The solution for the release 16 should also cover the trusted access. So having only N-free AWF is not quite the way to go forward.
Okay, cool. I just do some homework on that. If you have more exact information, you can share on the list.
Again, you can refer it to 23501 architectural picture.
Okay, cool. Any other questions?
Thank you, Zen.
Thank you.
So we've got 3 talks about individual drafts. I'd like to ask people to try and keep it to 10 minutes so we get half an hour discussion at the end for future topics. 10 minutes each, I mean, for each presentation. You're this one? Initial path selection, I think.
Okay, thank you. Hello, everyone. This is Zhu Jianjian from Huawei and the colleague of Dr. Cao Zhen. Oh, sorry. Hello, everyone. This is Zhu Jianjian from Huawei and the colleague of Dr. Cao Zhen. And now I will introduce one topic, initial path selection for MPTCP for collection establishment in MPTCP. Next one. Okay. Currently, master flow is initiated on the path which is decided by the default. And after its success, the other subflow will be set up. Take a mobile phone as an example. As we know, there are at least 2 scenarios deal with some problem using current scheme. The first one, next diagram, the first one, if the initial subflow cannot be established on the Wi-Fi flow, on the Wi-Fi path, there won't be connectivity, even if the LTE path is available. And the second diagram, if the initial Wi-Fi path is worse than LTE, obviously there will be some suboptimal performance. Okay, next slide. And in the previous meeting, Ruby was proposed. As we know, the first two downgrade and break before make solution put a too high burden on the server side. Therefore, it's difficult for the implementation. The third timer-based solution is with some timeout netison still. And the more collection created by one application, more time cost will be paid by the user. For example, the video downloading provider split one file to several segments, and every segment will trigger one new collection. So, user the timer-based solution will add netison to every collection. We think is not a. So we think still some improvement needed. Okay, next one. We propose, this is why we propose the new logic initial path selection. This initial path selection scheme can work together with timer-based solution, like diagram. At the very beginning, timer-based solution is used still, but when some information gets acquired already, the better initial path can be selected directly. Then timeout latency will disappear. Just like this diagram, also mobile phone example. This diagram will show the benefit. As our expectation, the initial path selection scheme used only the first collection is still with some timeout and latency. But all the later collection initial subflow will be on the LTE path. Therefore, there's no timeout and latency anymore. Okay. Oh.
Hi, Alan Ford. I'd just like to say that this whole approach is discussed in the heuristics in 6824 BIS anyway. It's just maybe you should cache working addresses and non-working paths. It's a fairly obvious approach to this kind of thing.
Oh, okay. Next one. Question? Okay, next one. Okay. And in our new logic, what path infer can be used is very important. We list some candidate here. The first one is the radio singular strength. And this parameter is global to all collection. Therefore, it can be shared by the collection, either same collection, same application, or different application. And like 3, round trip time, loss rate, and RTO event is local to each application. And we think it's much more suitable to be shared within one same application. And the next one is economy attribute. We think the new logic may cost more than the default one. So it's better to introduce some control from the user. Therefore, we think we can provide a new API for the user to control. Okay, please.
RSSI, it is not enough. It is used in the context of the cellular. If you want to use signal strengths, you may also consider information regarding to the interference level.
Yes.
Also, in the context of using Wi-Fi, you already have defined in Wi-Fi a global metric, practically being capable of providing you information of achievable data rate over different type of access classes, which may be a suitable metric to be used generically if you really start looking into metrics. Furthermore, I would like to drive your attention to one of our drafts that we have it on MAMS, Multi-Access Management System, where we have a long analysis of various metrics to be used across accesses.
Okay. And we also think some more information needed. Okay.
Yeah, I was going to echo that. In mobile, I would be looking at CQI, rather the signal to noise strength, rather than just RSSI.
Yes. Yes. And at this moment,
That was
the
Chris Seal for the note takers.
Should have said.
Christoph, I just want to say that the selection of the initial interface for starting a connection is really a big problem. It has a big impact on the performance, but it is independent from MPTCP. It is for TCP, Quake, MPTCP. It's the same problem. So we have to think about if you want to think about the solution, try to not design it for MPTCP only. Because
I agree with you. I agree with you. This is just one. This is just one feature we try to implement for MPTCP. It can be extended later for MPQuick and also some other multipath policy.
I'm Stuart Cheshire from Apple. I think I was thinking very much the same as Christoph. He beat me to the microphone. I was surprised in your presentation I didn't see any mention of happy eyeballs, because this sounds exactly like you're describing the happy eyeballs problem in the very narrow scope of only applying it to multipath TCP. So if you're not aware of that, you should look at the existing RFCs on dealing with this problem, because this is something that has been I can't speak for Android, but on iOS for many years on your phone, if you have Wi-Fi and cellular, then it will try to choose which one is working best with a preference for Wi-Fi. You talk about the users may not want to use mobile data. There is a switch in the settings. It's called Wi-Fi Assist that lets the user control this. So you may want to look at what's already shipping in existing products for some guidance for this.
Okay, thank you.
Okay, to reply to Christoph, yes, this should be a general solution, not only for MPTCP. So luckily, Spencer would like to organize some side meetings on the PIPC, which is a performance implication of the path characteristics this Thursday night. I think we can have more discussion there.
So I think we'll close the mic on this discussion after Alan.
Okay. Markus Arment, yeah, I agree with Christoph if he says this needs a solution maybe on a lower layer. But regarding multipath TCP, I think it's not a good design decision to limit a multipath protocol to single path capabilities at the beginning.
Paul, I just want to make a very quick point to Stuart's point on happy eyeballs. We had looked at it in the past, and one of the problems with it, and we've discussed this in some previous IETFs, was because of the keying material in the initial exchange, we've got replay attacks to worry about in MPTCP, which make the happy eyeballs approach slightly less easy to use than in some other scenarios. So I think this would be something valuable to come back and look at in a more generic sense, as you and Christopher said, but we just need to be aware that there are some uniquenesses about MPTCP where this doesn't so easily fit.
Thank you, excellent. I think we need to move on to the next presentation.
Just a last comment.
No, I'm sorry, we've got to
okay.
move on.
Okay.
You done?
Okay. Last one.
Oh, you got one more, sorry.
Yes. Last one. Okay. Just a conclusion. Okay. So, and this here is the conclusion. Like so we believe this new scheme initial path selection is an issue that need to be addressed by our group. Even if most of the decision can be made based on local information, and we suggest an information document around the best practice is needed, and maybe some more extended API, for example, to provide an interface for user control is needed also. Thank you, that's all.
Thank you very much. So Viet Hong, are you there remotely? If you request, I can then push the red button to get you in so we can hear you.
Can you hear me? Excuse
Yes.
me. Okay.
Yeah. Hi.
Okay. So I'm Huang from Usilivang, Belgium, and this work is present an alternative way to support the path managers, and it uses eBPF, which is specific for Linux, at least for now. Next slide. So the path manager in MPTCP is about which path to create or remove and which address to enable. And it should be controlled by the applications or users. Next slide. So at the moment in Linux MPTCP, it already supports a framework to support different path manager that based on netlink. It is allowed to allow user to write the path manager in the control plane in the user space. It provides a clean layer, but it's not without issues. First is netlink messages may be lost, and it may need different separate facilities to support various features, but maybe necessary features like we need to set or get different information from subflow level. We might need to get the notification from the TCP state change, or we may want to accept or refuse the subflow request from the peer. Next slide. Okay, so what about an alternative way based on eBPF? The first motivation is the performance, but it also supports TCP state tracking with TCP BPF, and it's also easy to apply the custom policy on the subflow establishment. It can refuse or set the subflow based on the current situations. But with this approach, we are currently restricted by current eBPF limits, like the length of the BPF program is limited to 4,000 instructions. There's no loop inside the program, etc. The second thing is that it looks like it's maybe less layering separations. And because the BPF program can be called from different contexts, so the locking may be trickier. Next slide. So our prototype with eBPF for three main jobs. The first is to track the events. We use the new, we create a new TCP BPF callbacks. So it's based on the TCP BPF in the mainstream Linux by Lawrence Blackmore, and it already provides different hookup for different phases of TCP connections, or when the connection state changes. It allows to read or write to many fields of TCP sock directly or indirectly. The second thing is to store the address and subflow. We can use the BPF maps. And the last thing is to open or close the subflow. This one is an action, so we need to add a new type of function. Next slide. Okay, so at the moment, the amount of canon chains for the framework is around 300 live codes. And for the path managers, we can write it as the BPF program, which is without any canon chains. So like for minimum version of NDIF path manager is around just 20 lines of code. And for full mesh path manager is much more complex, so it's around 200 lines of code. Next slide. There are many open issues now with current prototype. The main issue is how to handle the event of the local IP address change, because the TCP BPF is based on the C groups. So the scope of the BPF program is the C group. And let's say that we have many C groups, then we need to send the event to multiple BPF program on each C group. The other thing, like remove subflow, we can do similar ways like open subflow. But in fact, for the most common case, that when we receive a remove address options in Linux NPTCP, it already close the subflow automatically in the kernel, so we do not need to do that. If we want to track the state of the subflow, we need to store them, or we need to query on demand, and maybe store them in the BPF map. The next thing is, at the moment, it only supports IPv4, but to implement the dual stack support is not too difficult, because there already other helper functions do that. And the last thing is, currently it does not support multiple path manager. For example, if we want to have a different path manager for different network namespace, so that's another issue. But it's not immediate one. So next slide. So next slide. Okay. So to conclude, the eBPF make it easier to extend Linux NPTCP. So with good performance, I should put a question mark here, and it should be verified later, but that should be the case. Well, in fact, at the moment it's only for Linux, but FreeBSD may support eBPF in the future. So. And the details of the work is in the recent paper that I have put in the NetDev talks that you can see in the link. And for the source code is available on the GitHub. So that's all for me.
Thank you very much, Hang. Any quick questions or comments? Okay, great. Thank you very much.
Okay.
How are we doing with the blue sheets? Is there anybody who hasn't signed it? Where? Oh, so down the front and along that back corner. Who's like? Thank you. Could you? It's coming through. That one, and you want that one.
Okay, so this is a presentation on 5G session continuity support in NPTCP. Who am I? Yeah. I'm Xavier Defoy here and presenting on behalf of my co-authors. And so this draft is an evolution of an older draft presented in IETF104 in Montreal. The scope has been really reduced now to only 5G session continuity in an effort to make it simpler and more focused. It was revised based on feedback from discussion in Montreal. So one question was, what is the impact on the NPTCP protocol? So now the draft is really focusing on end-to-end issues impacting with potential impact on the MPTCP protocol. And also some ideas for alternative solutions were provided, and they are presented in the draft. That's a client-driven solutions or approach that we will have later. So as a summary of changes, quickly, we only kept the 5G session continuity related text. The local impacts on the client basically are still there. They are in appendix. And the draft is now more clearly describing end-to-end issues. And potential issues, I mean, basically that's issues which are impacted by the behavior of the remote peer, because the remote peer is not aware that an IP address replaces another one. It's just a new IP address. And so potential issues will be identified. We will list them in the next slide. And so several alternative approaches are also listed. And these end-to-end issues should apply when MPTCP is used between a 5G device and an MPTCP server or proxy. So just to recap what was presented in Montreal quickly, in 5G, session continuity is only, session continuity is not hidden from the MPTCP stack, at least in some cases. So when both mobility support and maintaining low latency are needed, 5G will use a distributed mobility solution, either in make before break or break before make mode. And in these cases, a given connection will appear as a succession of IP addresses when the device changes anchor. So we identified the following issues. With make before break, the old subflow may be interrupted abruptly when the network reclaims the resources related to the old IP address. And that could result in losing and resending in-flight traffic. So that could have an impact on performances. And with break before make, MPTCP may switch back and forth between backup and active subflows. So instead of waiting for the break before make transition to complete. So that may be unwanted behavior that may have an impact on battery usage, for example. So in terms of alternative approaches, so the first approach, since these are not breaking issues, we could just keep using MPTCP unmodified and then look at the real effect on real applications and take it from there. A second approach would be to use a client-driven behavior. In this case, a few changes to the protocol could enable the mobile client to drive the remote peer. So you could gracefully close a subflow that would help with the first issue. And you could specify a timer for the backup that would be basically help for the second issue, that basically behavior that was provided in Montreal. And then the last approach would be to have the client communicate session continuity information to the remote peer when adding either implicitly or explicitly an IP address. So in this case, you would let the remote peer know as much as the client, so you could run basically the same algorithms or on both sides. So that would be more complicated on the MPTCP protocol side, but maybe a bit simpler on the actual policies. Then in what you can basically transfer over MPTCP, that would be the session continuity IP address type that's defined in DMM. And that's used, that has a one-to-one mapping to session continuity modes in 2HPP, but that could be also applied to other types of session continuity. And you would also provide the original IP address index. And I think after you have a range of other solutions that you could have in between, because actually all of these related IP addresses could also be inside a group. And I think grouping was a feature which was introduced some time ago in MPTCP. We did not make it in, but basically that could be used in this context. So as a conclusion, this draft summarized what has been discussed so far, and our goal was really to provide something useful that would help future work in this area. In terms of future work, if the working group decides to describe path management, for example, that maybe that could provide some input to that draft. And also, as 5G networks become more and more available to experiment with real applications, it will become possible to further validate and complete this analysis. So actually, I would like also to propose adding this 5G session continuity support as a potential new item to consider for the future MPTCP work, but maybe in the umbrella of 5G adaptation, or basically topics which were discussed on Monday's side meeting. So maybe that's kind of a smaller issue within the larger issue of integrating with 5G. So that's it for the presentation. Thank you.
Comments and questions, please.
Yes, so Florin Măbăscu, Broadcom. Several issues with contribution. First of all, release 16 in ATSSS study item and now work item introduces a notion of a multi-access PDN. For the ones which are not familiar with 3GPP terminology, a PDN, it's a physical network. For example, your handset device connects at least to an IMS network, which provides IMS services, and the internet network. Just terminology. Release 16 has this multi-access PDN in which one address is associated with a terminal, although two other addresses may be associated with the accesses over which the multi-access it is going to be provided. So this is not actually discussed at all in this context. Second thing, practically, what are we trying to achieve? You had a comment earlier that the terminal device may not be able to identify a particular address that it is new if it is associated with a previous address. This is also not the case, because every single terminal would gonna know the current address if it is associated with cellular or double LAN access. So this is, again, a non-starter, the way I do look at it.
Okay, actually the client knows that you have IP session continuity, so you will need to have some form of support in the path manager and the client, very probably, because when an IP address replaces another one, if the first one is a backup, the next one should be also a backup, for example. So you have like a continuity of policy that you need to have. So the client is aware of this continuity between IP addresses, and the remote peer is not aware of that. So basically, the goal of this work was really to study, to see what type of issue you could get because the peer doesn't know about this relationship. So you have either, that's why you have several solutions. Either you ignore the problem and basically you may get some performance issues, but nothing breaking, seemingly. Or you can have the client which knows about the continuity aspect. Basically tell the server, do this, do that, basically control the server so that performance, good performances can be maintained. Or you can tell the remote peer, actually, these addresses are related to each other, and this one, that's this type, that's maybe non-persistent, so you can expect it to go out and to be replaced after a break. So you see, you have different strategies you can have, and that's, I mean, there may be more, okay, with respect to the proxy, I'm not sure, but my understanding is that the fact that you use a proxy or not, basically you have this type of, you have this problem because the proxy is acting as a form of server from your standpoint. So that was basically the approach.
Yeah, Srikandavali. So the key proposal is to relay the SSC modes to the peer. Is that the
Not really. I mean, that's one possible issue, but here I think we were careful to just trying to expose the problem and then gather solutions. So that's why you have a solution where the client tells the server, "Oh, here I close this subflow gracefully, so that there is no nasty you don't need to repeat some segments." That's one client-driven way. Then you don't need to send the session continuity mode. But actually, session continuity mode, it would be the address type, right? Non-persistent, graceful replacement, that type of thing. The second solution would be to transmit that. Right. But I think there is maybe even a third solution in between, where you group the addresses. You say, well, group 0, that's that's all addresses which are related to each other, but you don't necessarily give the type. So you have a range of solutions, and maybe that would be after some experiment implementers could make a choice, or designers could make a choice.
Right. Yeah, I think mode indication alone may not be sufficient. I think, yeah. Thanks.
So, sorry, no.
Just the mere mode indication alone to the peer is not going to be sufficient. SSC modes are, I think there has to be additional considerations.
Here, yeah, okay, we can talk about this. Here, that was basically the mode and the address type plus the initial address that was used with MPTCP. So if you change like 3 times, you would have maybe, it's like you have one group. They all belong to one group, and each address can have a type associated. Does that make sense? Is it?
Need to analyze this. I'm not entirely sure I got it, but thanks. Yeah.
Okay, thank you.
Hi, Lars-Sager. Do you have any data that quantifies the problem of not doing anything? You get these 3 options on your. Can you go back one slide, Phil, maybe? Yeah. So do you have any data that shows what happens with bullet 1?
No.
Okay. So I would suggest that we have this discussion when there is some data that quantifies the magnitude of the problem.
Yeah, exactly. We need to start somewhere. We started from the specifications. The reason why we don't have data is because.
So spending engineering cycles on something when we don't even know whether there is a problem and how big it is seems premature.
Do you have a plan? Do you have a plan for when you might gather some data or not?
Basically, it depends. Basically, if there is some interest in this, if people think that there is a reason to go forward. But basically, we need to have access to some 5G network where we could do some tests. And for now, I don't have access to that.
Even the simulation data would be okay, right? I just want to see something that convinces me that something is needed. Because these mechanisms aren't necessarily free or uncomplicated. But so if you say that performance suffers by 50% and for 2 quarters of 2 connections or something, but some just MPTCP and TCP, right? We always like to see TCP improvement proposals come with at least some data that sort of shows here's how it was before and here's how it could be after, and after is hopefully much better than before. And this is what I would sort of expect for these proposals as well.
Yeah, we started from the spec that you.
Yeah. So start with data.
I will not propose to make a change in the design before data. I think that was the analysis part.
Yeah. So I would be much more receptive to any proposal, frankly, right? If somebody sort of at least try to quantify in some cases what the problem and the benefits could be, that would be very nice.
Thank you.
Okay. Now I put my FreeGPP hat, so different part. From our perspective, for FreeGPP, we have very clear items which are a priority from the point of view of multipath TCP. We already specified those. We would like to see them actually handle them as priorities. This item has not been an issue in the context of the 5G discussions in FreeGPP, and at least 5G development and standardization is still owned by FreeGPP.
So I think, Florian, what would be good would be to understand what those priorities are for 3GPP, maybe you could send a mail, because I guess it's...
So you already had a
online
study
answer.
diagram which is fully specified in the context of ATSSS. Multipath TCP, it is publicly available. Multipath TCP, it is one of the main aggregator mechanism. For that one, it's already sent to IETF a couple of drafts that are considered priority, which I mentioned earlier in this discussion.
Okay, so we need to... Maybe we should talk afterwards, Florence, so we can make sure we highlight that to the group. And if I read that document, will it tell me what is needed from Multipath TCP
Correct.
working group?
You
It
have
will do.
it. It is fully described.
Okay, the line is closed. We're going to move on to, but you can stay where you are because we'll get to the open discussion shortly. Thank you. So we've got about 25 minutes left. So I'll just do a couple of minutes summarizing what happened on Monday. And Anna has a couple of minutes slide, so we'll do that, and then we'll throw open to a more general discussion. Yeah, so we had a good session for about an hour on Monday morning with a nice number of people. Thank you for that. Lively was supposed to be complimentary there, not... I realised afterwards you might misread that. So we talked quite a lot about the path manager and scheduler, which are kind of related topics. And we've talked more today about that. So I think my summary of where we're at is that this ATSS 3GPP group are interested in output from Multipath TCP working group. The time frame for their work seems to be over the next few months. So it kind of seems a priority that we try and understand that quickly and work out what to do. We got into a discussion about sort of possible mechanisms, which I think we've had in the past. We've had discussion about possible mechanisms, and if you remember, we never reached any consensus when we were talking about the RFC and the BIS about adding anything more than the backup bit, the MP prior. Now, there are all sorts of things you could do. There is room for new sub-option types. There's all sorts of information exchanges you might want to add. But I think before we get into mechanisms, we need to think more about the scenarios, the requirements, what the problem is before getting into that. So that was my summary of that set of, or those two topics, the path manager and scheduler discussion we had. We had some discussion about API. So this is between the application, interface between the application and Multipath TCP. There was a suggestion to update the experiences document with the latest experiences, which seems a good one to me. We had some discussion about robust establishment, and we heard a bit more about that today. So there's a bit of disagreement there. Some people think it's useful. Some people are concerned about about various problems of scalability and things. Marcus, who's done work on that, he's planning a draft for Montreal, and we heard a bit of related work today. So my suggestion was we park discussion until that point. But obviously, people can discuss on the mailing list as they want. So I think, Anna, if you do your quick talk now about the API issue, we'll have, if there's any discussion on that, and then we'll go to more open discussion.
Yes, so as Phil said, when we met on Monday, we had some discussion about the...
That's not there. It hasn't uploaded it, has it?
Sorry?
Is your talk there? It's not, is it? I uploaded it.
Okay, that's okay. I can talk about this.
Let's try.
So there was a discussion about APIs and what information you should convey to MPTCP for selection of your or paths or controlling the scheduler. And in this context, we have the ongoing work on transport services in the TAPS working group. So I thought it was quite good for this group to know what is going on there because it's closely related. So the idea of the TAPS group is to specify an abstract API for the transport services. So instead of having your implementation directly connected to a given transport protocol already at the compile time, you use this API and then you have a transport system underneath that allows you to select the protocol at the startup time. And there we also have some of these mechanisms that were mentioned today in relation to how you select a path, and the happy eyeballs mechanism between different protocols is built into this. So the way you in TAPS convey what you need as an application is through a set of transport properties. And there is currently a multipath transport property specified in the TAPS API draft. This property is currently just the on-off selection. So you can tell if you prefer a connection with multipath support or not. So clearly we have had discussions in the TAPS group that this also is something that we need to have a bit more expressive in the end. But for the first version of the drafts that have been out, this is an on-off property. So that would then allow you to specify if you prefer or require or prohibit, for instance, the use of multipath support. So in the slides that we cannot see right now, but that I guess will be in the meeting minutes later, there is also some links to the relevant drafts in this TAPS working group. So there are three main drafts. There is the architecture framework, there is the interface draft where we specify the transport properties, and there is also an implementation draft. So yeah, here they are. Yes, so I guess I'm on the last slide. So these are the three core TAPS drafts. If you want to see the structure of this, there is a GitHub repository. I just also opened an issue there for the multipath part because we have discussed to have what that interface needs to look like. And of course, you have the TAPS working group page if you want to see all the documents related to the draft. And in the implementation draft, you can also see some of the racing that was discussed earlier between the protocols and how that could be done. Yeah, I don't know if we want to go back to any of the overviews, but yeah, Tommy.
Tommy Polly. So I noticed, because I'm on the TAPS documents, I noticed that you opened an issue for improving the granularity of the multipath stuff. I added a comment back of what we're currently doing in our TAPS implementation on Apple devices, which is essentially using the enum that Christoph has defined of, we have, you can have it off, but then you can have it in handover, interactive, or aggregation mode. I think that's a fine thing to take in, but if anyone in the room has other thoughts of tweaks they'd like to see to how that could get standardized as an API surface, please let us know.
Yes, and that was exactly the point of this hands up. So yes, we appreciate to get the input from this group, of course.
Any other questions or comments? Cool, okay. Thank you. Sorry for the slides not being there. Okay, so now we've got, I don't know, 20 minutes left or something. I'll throw the mic open to any discussion people want about where the working group should go next, how we should look at deciding what to do, how we should approach this path manager and scheduler problems. The floor is yours. So having had lots of discussion earlier when it was slightly off the agenda, we now have none when it's on the right point.
Christoph, with the path manager and scheduler problem, I have already said that in the past a few times, and I really think it's one of the biggest problems for Multipath is that there are two conflicting goals. There's the client. On one side, you want to have the best performance, the best user experience. And on the other side, you want to avoid using the most costly interface, right? Reduce the cost. So those are conflicting goals, at least on a smartphone. So that means that the scheduler needs to make trade-offs, which are not always geared towards the best performance, but basically defines kind of some performance thresholds. And once the performance goes below the threshold, then you start using the cellular interface. Now that is fine on the client, because on the client I know what I'm doing and I know what my goal is and where the thresholds are. But these thresholds need to be communicated to the server, because when I'm connecting to a server, or at least a generic server, I need him to respect those thresholds. Otherwise, I will be consuming too much cellular data. And that is a problem that's not easy to solve without additional signaling or some other ways. On our side at Apple, the way we deploy it at the moment is, well, we know to which server we talk, and we configure for each service that requires a certain policy, we configure the server specifically. So that means basically we have different server infrastructures for each service that requires a certain policy. So if one would want to now deploy a generic MPTCP service, he wouldn't be able to really do this, because he would need to specify some kind of scheduler on that infrastructure, and that scheduler will not be able to satisfy all the policies. So some signaling from the client to the server to communicate the thresholds or the policies would really be needed for generic MPTCP or multipath deployment.
Christoph, can I ask you, going back to Lars's use CE, use congestion experience point, have you tried that out? Does that work well enough in your case, or?
Well, that may, like trying to slow down the other side, like with congestion experience, or maybe setting the window or things like that. That works for throughput, but if the policy or the thresholds are latency based, then that doesn't work yet. And like for our Siri use case, that's literally what we do. We have latency thresholds upon which we start using on cellular.
So I'm standing on the side because I'm not sort of particularly on this. So I chair Quick, right? So this is Lars again. I chair Quick, and Quick is probably sometime later this year gonna start doing multipath Quick, and a lot of the lessons that we've learned with multipath TCP, but also a lot of the open issues that we're still having, like this, right? Path manager and scheduler for like the last 10 years have been this things that we have some early examples that they don't really work well in all cases, and we don't really know what the principles are and what we should do. So a lot of those components actually apply both to multipath TCP and Quick and any other use of multipath end to end, right? And maybe it would be worthwhile to figure out whether there's a group here or a directorate or whatever where we can have a discussion about those maybe more principled things that then apply to different transfer protocols. Because I mean, the Quick guys are really good at reinventing everything, but it would be very nice if we didn't need to reinvent the stuff we know from multipath TCP, or if we could join forces on making some progress on those things that we haven't figured out for multipath TCP yet, but we are gonna need to figure out for Quick too, right? And so I think that might be some way to think about what the future for the MPTCP working group could be. And that for the MPTCP specific parts, right, you could then almost maybe go into maintenance mode or focus on something else, because these harder problems would be solved in another working group or maybe another research group, right? It might even be that we're really not where we need to be in order to do engineering here. So that's why I'm sort of standing on the side, because I don't know if this is a discussion you want to get into, but I think the upcoming push for quick multipath will make a lot of these things very, very urgent, more urgent than they have been in a long time.
Markus Arment. Yeah, and that's why I think it's pretty much important to collect path scheduling and path manager mechanisms or mechanisms inside an informational document where then Multipath TCP or Multipath Quick can profit from.
So going around Christoph comment, the issue is not only on the handset, but you also have the issue on the proxy side. As a proxy may implement a load balancing scheme that may not have the scheduler use based on whatever quality of the link or quality of the path. So looking, I mean, at least the way I do see these discussions, and also being direct participant in other SDOs on this type of discussions, like it or not, a policy-based type of decision, you may need to take it into consideration into the context of the scheduler, and how this can be better put in place may need to be discussed properly.
Yeah, last second. So there's stages here, right? So we already have unsolved problems in multipath TCP, but also in general multipath when it's just about the client and the server who may, for example, have a latency objective or a throughput objective or a mixture of something over a given connection over time, right? And it is only those two entities try to make best use of the multipath fabric in between. And that is already hard, and we don't have a good solution for that generalizes to, arbitrary use cases or even, different use cases. And it gets harder when the network obviously wants to maybe influence or have an opinion about the use of that multi-connected fabric, right? And I think teasing apart these sort of, desires is a useful step, right? But I mean, I'm one of the reasons I'm sort of hesitant about this whole policy and network aspect is that I know we already don't have a solution if we, for example, treat the network as a black box, because the client and the server and the workload demands a mechanism that we don't quite know how to do. And it gets exponentially harder if the network also wants to have a say. And then you get into this whole, what if what the network wants isn't actually aligned with what the client or the server want, or if the client and the server disagree on what they want. So this is quickly becoming intractable. So I think for multipath TCP and also for multipath Quick, carving out some part of that problem dimensional space where we can maybe make some progress would be very, very useful. And my gut feeling is that policy is not going to make it easier. But we need something that works well enough, because otherwise we have the same thing that multipath TCP had great potential and it works really well for some cases, but it hasn't really sort of delivered on being broadly applicable, which is what we initially hoped when we did it, right?
Do we have?
Mia Kulevant, area director for this group. So I did hear a lot of interesting questions, but I would really put them into the category of being a research question. And we need a venue to discuss these questions, but it might not be an IETF working group, right? Some of these questions do have a relation to ICCRG, because there is a relation to congestion control, and ICCRG also looks into AQM and scheduling mechanism in the network. So there's a big overlap. If that's not a good idea, we can also figure out if we want a separate research group for it. but I don't want to have a research discussion in the working group here. The other thing I heard is about some minor extensions we may need, but like fortunately we have a working group for minor extensions for TCP. This is also TCP. So any of this work, if any of this work is needed and gets mature and we want to standardize it, we have an option to standardize it outside of this working group as well. And the third thing I heard was questions related to interfaces, and we have a working group for this, as Anna pointed out very well. So there's a strong overlap with tabs here. So right now, I don't see any reason. Also, like you're all here, and it's great that you're interested in MPTCP, but I don't see any reason to keep MPTCP as a special snowflake anymore. MPTCP is part of the TCP protocol, and it swaps over into different working groups, and that's where we should have the discussion.
Can I say something? I don't think that's just research question, because that's basically operation. A lot of things that stems from the operational experience that require some spec to be changed. And secondly, technically that's the true. And secondly, because we have 3GPP and also BBF expert here, and they are also looking at this, and the liaison of existing working group to be a liaison should be very helpful for the ecosystem.
That's what I said. So there are many research questions to find a solution that may change the spec. But so far, my understanding is these changes to specs are minor, and therefore they don't have to have their own working group. I don't want to discourage anybody to do this work, because I think it's very interesting, and I see operation and deployment. It just might not need an own working group. That's the only difference.
But actually, it'd be much easier you have working group solving this problem and looking with the expert here. If you are shifting to ICCRG or other research group, then the attention of the practitioners will be distracted somehow. They don't know if their impression is that MPT working group has been closed, and they don't know ICCRG has been looking at that, for example.
My concern is just the other concern around. We have experts in ICCRG who know congestion control, who have a lot of experience. And if those experts are not in this room, we cannot have this discussion here.
So control is just one part of the problem, very small part of the problem, right? We have many components that is purely, coupled with the MPTCP stack instead of the congestion control as well. For example, the path manager, scheduler, and also the Ruby stuff.
So, Philip Eardley, I partly agree with those comments. I mean, to me, I'm not sure we actually understand the problem that we're trying to solve yet. So it's a bit hard to know how much research is needed, or if it's something that actually can be easily solved. And I think there's not been agreement on that at all yet.
So we don't have working groups that try to figure out if there's a problem. You try to figure out if there's a problem first, and then you go to a research group. Research working group. Yeah. So the people are wading in it immediately with this sort of mix of problem and solution, and
So do you want to do a poll, or we don't have to right now?
Do we have to what?
Ask the group about the options.
No. Let's try and get through the line. We're getting towards the end of the meeting, so the time. So if you're standing up, you're welcome to say something. If you're not, I suggest no new people. So yes, I can see 4 people standing up, but
so at least I heard before, at least from Lars, he may correct me if I heard it right or wrong. It looks like that you do have an issue if there is a peer, either proxy or terminal, that may need to implement a policy. And in this particular case, again, putting my 3GPP hat, I would say that you do have a problem. And we do have very clear requirements for the need of having both policies in the Multipath TCP scheduler. So then we may want to see it addressed, not as a generic research academic or whatever.
So I think please send the link to that document, and let's have some homework for people such as me.
So just to comment to that, I mean, for ATSSS, it already has a side channel to communicate the policies, right? And then, so it's kind of, at least for that deployment, it shouldn't be that big of a deal.
I mean, I didn't understand that the issue is communicating the policy. The issue that, at least I understood from the comments, was that the overall applying the policy together with whatever the scheduler of the multipath TCP may be an issue. Yes, communicating the policy, that's not an issue. Even generically, we happen to have a draft on MUMS that would provide something like that.
So people who are Marcus and Tommy, and I don't know if there's anybody lurking around the corner who wants to say something, 30 seconds each, because we're over time, yeah?
Okay, independent from the policy discussions, and I think I'm also active in the 3GP and BBF stuff, and I think we learned now that they are very much interested in multipath TCP, or it is even defined that they will use multipath TCP in future. And so what I want to ask is, in principle, I think it would be good at least to have an informational document at IETF which is describing traffic scheduling and path manager mechanisms, so that other standardization organizations knows about what is maybe available, what is the main intent of different mechanisms. So it has not to be described in detail, so no algorithms or code, but at least the main intent of different mechanisms. And there, I want to ask you, Mia, do you think that is really research, or what is your idea about that?
So if people think such an informational document is useful, we can do this in the IETF. But as Lars said, this is also a topic that is relevant for other protocols as well. It's not MPTCP specific, so this might not be the right group for it. I'm very supportive for such a document, and and as also the work, like if you need an extension for a priority, please do the work, please write the documents, we will find a home for it. I don't think we need a separate working group.
Tommy Pauly, just to the people who are earlier in the line, I'd like to encourage you to not see some of the comments of saying, oh, should the working group close, as like a threat to the work. The work is still very important. MPTCP, clearly still exists and is still very valued. And to some degree, like what we were saying earlier with Multipath Quick, that's going to be a whole lot of work that will go from research into hard engineering, and maybe it will make sense in the future to have just a multipath transport group that can affect all of these. And I imagine these other groups like 3GPP will want to also handle Multipath Quick well in the future, and maybe having a new burst of energy in that other direction will help actually more than hurt.
Do you really need to say something?
Yeah, just actually I would totally agree with him before. And we do see this interest not only from 3GPP, as I also happen to be in other groups like IEEE, having a generic multipath. We would like to be able to use IETF standardized protocols, making sure that they are, but also needs to be, from this side, the only concern in all of this organization is a timeline. Like, for example, I would need something for the release 17 timeframe, which is next December. So there are multiple issues, but practically agreeing with the previous speaker would be very beneficial to have a working group addressing the multipath related issues, not only multipath TCP. That would be the point.
Last comment.
Yeah, I still don't understand why we need to close the working group when we have very important issues to solve. And also, I think that at least we should do a poll to the group of people here or on the list.
That management decisions about how the work is managed is not a working group decision. It's for our manager.
I mean, the first question, when we have important questions to solve, we want to close the working group. I don't understand the logic.
Yeah.
The working group has a charter. We did everything that was written down in the charter, so that's usually the end of a life of working group. If you want to do new work, we can talk about it. It doesn't mean it has to be done in this working group. And also this working group has currently one active working group document, which is in processing. So basically it has 0 active working group documents, right? If the time between you get to a solution and this working group finish their work that they do is like very long, then we probably need a new working group at some point.
So
and like one more quick comment, like if we close the working group, we will keep the mailing list open. So that's still a point where people can send questions and whatever. So I think that's valuable.
Can I assure the people here that I will, on behalf of the people who want to do lots of stuff, will be doing my best to make sure that there is a home for it, even if it isn't called Multipath TCP. That is not a question. I think the question is that we're well past time. So thank you very much for coming. And we'll see you all in Montreal, whether it's in a group called this or somewhere equally good. Thank you.
Anybody not signed? Everybody signed? Yeah.